Welcome back. So I was watching a podcast I made earlier on this problem, and I wanted to clarify. The answers were correct. I especially wanted to clarify speeding up, slowing down, and then I also wanted to make sure you could read the answers. So obviously when I kind of fixed up my PowerPoint here, I decided to, number one, put values on the y, making C easier to interpret, and I decided to use 2 pages. So you can read it better. And secondly, I want to go over speeding up and slowing down in a little more detail to make sure that that's clear to you. All right, so the times given on the podcast were correct, but I want to make the reason a little clearer for you, okay, with a clear explanation. All right, so it is speeding up from here. Right, so it's speeding up from 1 to 2. And it's also speeding up from 5 to 6. All right, let's talk about why it's speeding up at those times. So from 1 to 2 here, the velocity is below the x-axis. So that means velocity is negative. Right? Notice the slope of the line. The slope of the line is negative. That means that acceleration is negative. Let's look over from 5 to 6. Right? So from 5 to 6, velocity is above the x-axis. Right? So that means velocity is positive. The velocity curve also has a positive slope. That means that acceleration is positive. So notice they match. Right? So our function is speeding up from 1 to 2 seconds and 5 to 6 seconds because the velocity function is positive. And the acceleration, so it's positive because it's above the x-axis. I'll add that to it. Let's make a really clear answer here. An AP test worthy answer. It's above the x-axis. And the acceleration is positive. I'm going to abbreviate velocity, and that's because v of t, that's our velocity curve, has a positive slope. Looks like the word slope. Slope's not a word. Slope. Or, and that's our first one. That's the 5 to the 1 to 2 part. 5 to 6, the velocity let's put v of t. I don't want to run out of space again. V of t is negative. And you know, it would be nice to, 1 to 2 was the negative. They were both negative. I should have, don't write this. You know what, I want to make it match the times. I'm sorry. I should have been looking at the ordering of the times. Probably should re-record, but well, I think you're okay if I just rewrite it real quickly. All right, so the 1 to 2, they were both negative. I want to make it match the times. All right, so because v of t is negative, so I want to make sure it's very, very clear. So v of t is negative, and that's below the x-axis. That's how we know it's negative. So this part, by the way, goes with this part, 1 to 2 there. And acceleration is negative. Oh, let me put a of t. And we know a of t is negative because v of t has a negative slope. If your velocity curve has a negative slope, your acceleration is negative. Just like if your position function has a negative slope, velocity is negative. All right, so it has a negative slope. All right, so they're both negative. Or from 5 to 6, because v of t is positive, it's above the x-axis. And a of t is positive. And that's because v of t has a positive slope. We're going to have to move this. So as a reminder, we are speeding up when velocity and acceleration, I know I'm going to fit acceleration in that little teeny space, are both positive or negative. I think this reason is much clearer for you. It is a very AP-worthy answer, and you should write that in your notes. Now you can write that in your notes. Now that I've stopped erasing anything. I'm just moving this up slightly. I'm going to put the next part of our answer here, and I will probably write this and take a little less space. I'm going to maybe color code. So this was speeding up. There we go. And now we want to have slowing down. You know, I'll put a blue dot next to it because I put the lines in blue. Let's put a green dot next to slowing down. All right, and it's going to be slowing down here from 0 to 1. And here from 3 to 5. Right, so from 0 to 1 here, your v of t is positive, but a of t is negative, right, because the velocity has a negative curve. I don't think I'm going to write quite as much detail in the slowing down part because it just kind of follows along. It's the same kind of reasonings why the velocity is negative or positive, so I'm not going to add that twice since we already put it with speeding up. But we are going to explain why it is slowing down and about the difference between the signs of those two. So make sure you put that next to this graph if you still have space. And then here, notice that v of t is negative. We're below the x-axis, but a of t, our velocity curve, has a positive slope. So a of t, our acceleration, is positive. So we're slowing down because, and I'm just going to note that the differences in sign, because v of t and a of t have opposite signs at these times. Opposite signs, that's good enough. All right, so you can always, if this were an AP test, maybe just add a little bit more detail, but we have the detail for your notes in the speeding up part, right? We just added in the reason why that's slowing down. They have opposite signs, and we've put that on the graph. And hopefully with you labeling your graph and the reasons you have here, that is nice and clear for you now. Okay, so remember, when those signs on acceleration and velocity are the same, you're speeding up. When they differ, you're slowing down. Right? Because you can speed up in a negative direction, you can speed up in a positive direction, right? Or you can slow down. Right? So, and then of course it's constant from the 2 to 4. And oops, we forgot to mark one. I missed one of our slowing downs. Sorry, whoops. We have one more slowing down. So let's just squeeze that in. So from 0 to 1, here I almost forgot to mark this one. And so here v of t is positive, A of t is negative. Oops, almost missed one. I don't know, oops, -1, negative. I guess I decided to stop reading the graph. I've done that twice, like right at about 6 seconds. That's the end of me reading the graph. Move over a little bit. All right, maybe because I wrote the blue right above where the green should go. I almost forgot to mark that one. All right, so again, the signs are different. Let's just squeeze in the one other time. I'll just write small and I can fit that in. So it was also from 6 to 7. I almost forgot to write that in. It's a good thing I looked back at the graph to talk about when it was constant. And that was because V of t and, there we go, A of t have opposite signs. Right? So those were the 3 places. Right? So make sure you always read the graph all the way through. And then here's where it was constant. From 2 to 3, so V of t here, well, A of t, let's put that in, is 0. V of t is constant. If we believe that that's -3, which we'll say it's -3, it's at -3. All right, I put a value on there so that was easier to interpret. So let's just say it's at -3. All right, so we have a constant velocity of -3. If your velocity is constant, your acceleration is 0. And then one more time here, from 7 to 9, and I have more of this on the other page where I wrote the answers for B, C, and D, but since I have the graph already marked for acceleration and velocity for speeding up and slowing down, may as well put the other parts here. So I can review it with you. So from 7 to 9 here, the velocity is constant, and it's clearly 0. If your velocity is 0, so is your acceleration. And it's have to be, right? Because it's a constant 0. And if you're not moving at all, well, you can't be moving faster or slower. Stands to reason. All right, so hopefully this has made this graph a little clearer for you, and you understand how to interpret speeding up, slowing down from our velocity curves. And then here are the answers to the other questions. It looked a little crowded on my podcast, so here I was smart enough to use 2 pages. All right, so our acceleration is positive because of the velocity curve has a positive slope. Right, so it's going to be positive right there. Right, that's where your velocity curve has a positive slope, so from 3 to 6. Right? So A of t is positive. And then our velocity is going to have a negative slope anywhere, acceleration is going to be negative anywhere velocity has a negative slope. So right here, A of t is negative there, and A of t is negative there. If your velocity has a negative slope, your acceleration is negative. And then from here again, like I said, your V of t is constant, so your A of t is 0. And again, here too, V of t is constant and 0. So A of t is also 0 there. All right. So t equals 0, t equals 2. They both appear to have so for number C there, or letter C, when does the particle move at its greatest speed? If we call this -3 and this +3, because there's no values on my y-axis, and it appears like they are exact same distance away, one in the positive direction, one in the negative direction. Both appear to have the same largest absolute value. And remember that speed, let's add that to your notes. Speed is the absolute value of velocity. All right, so add that to your notes. And then, of course, the particle standing still from 7 to 9 because the velocity function equals 0. If your velocity is 0, you're standing still. All right. So if you have any questions, let me know in class. And that's the end of this podcast, but we'll be continuing on with more accumulated change. Thanks for watching.